If we see into the question, is hollow shaft of diameter 3 by 5 required to transmit 590 kilonewton at 110 rpm, the maximum torque being 20% greater than the mean torque. Maximum torque is 20% greater than mean torque. The shear stress is not exceeded 63 MPa and the twist in a length of 3 meter is not exceed 1.4 degrees. What is the maximum external diameter satisfying these conditions? If you say the internal diameter is D is equal to internal dia and capital D is external dia. We know the power is equal to 2 pi n t mean by 60,000 kilowatts. So T mean we can write as power is 590 kilowatts into 60,000 divided by 2 pi into 110 rpm. N is equal to 110 rpm and P power is equal to 590 kilowatts. So T mean can be calculated as 51218.95 Newton meter. We know that D is equal to 3/5 of capital D. So moment of inertia I P is equal to pi by 32 D power 4 minus zero point 0.6 D power 4, that is equal to 0.0272 pi D square. T max is 1.2 T mean. So T max is equal to 1.2 times P mean is 51218.95, that is equal to 61462.74 Newton meter. We know the relationship, that is T max by IP is equal to maximum shear stress tau S by R into G theta by L. So if you meet the relationship, it is radius, we will convert into diameter. T max by IP is equal to moment of inertia 2 tau S by D, or we can find out the diameter. IP, if you substitute this value over here, and tau S we know maximum shear stress 63 MPa, tau S is 63 MPa, and T max substitute this value over here, then we will get in terms of D, the equation in terms of D. So the function of D we will get, so D value we can calculate, D is equal to 17.87 centimeters. 17.87 is not there, so we'll again theta is equal to T max L by GIP, that is equal to, it is given as in degrees, so we can convert into radians. Pi by 180 is equal to T max is 61462.74 into 3 length is 84 into 10 to the power of 9 into point IP is 0.0272 pi D square. So D is equal to 18.006 centimeters, that almost equal to 18 centimeters. So option B is correct. Question is, a 6 centimeter diameter jet of water moving with a velocity 10 meters per second. The diameter is given as 6 centimeters, that is equal to 0.06 meters, and the velocity is given as 10 meters per second. Impinging onto plate smooth and inclined at an angle of 45. So theta is equal to 45 degrees normal to the plate. The impact on the plate when the plate is stationary, we have to find out the impact P. Rho square by g sine theta, where rho is 1000 kg per cubic meter, that is equal to 1000 kg per cubic meter into A is pi by 4.06 square into 10 square by 9.81 acceleration due to gravity sine 45, that is equal to, we have to convert it into newtons. We are going to get 1920.2 kgs, that is equal to 199.61 newton. So option B is correct. The question is, a cantilever steel beam of 3 meter span carried a uniformly distributed load of 20 kilonewton meter. So the bending moment M is equal to WL square by 8, that is equal to 20, L square is 3 square by 8, and IXX is given. So bending stress and shear stress we have to find out. Bending stress is equal to M by Ixx into Y, that is equal to 23 square by 8 to, we have to convert into newtons and millimeters. 1696.6 millimeter per 4 into 100, that is equal to 132.62 newton per millimeter square. 132.62 is only in one option, so option C we can directly mark it as correct answer. If we find out the shear stress also, shear stress is equal to V by P into D is equal to 20 into 3 by 2 into 10 cube by 5.4 into 100. Web thickness is 5.4. The diameter is given as 100 mm. So we are going to get 27.78 Newton per millimeter square. So option B, C is correct. Here the question is, in a water supply distribution network, the dead end system is not favored because the dead end system, for some reasons it is not favored. What are those reasons? We have to find out. So the reasons are given below, 1, 2, 3, 4. So if you see from the bottom, at the time of repair, service connections beyond the point of repairs are deprived of water. So at the time of repairs, the entire system is going to be deprived from the actual system. So option 4 is correct in case of dead end system. So 4 is correct, is in B, D, C. So go to the third point. It is difficult to maintain residual chlorine level at the dead ends. So it is very difficult to maintain the residue. It is also correct. So 3 is correct. So it is going to be avoided. B and C. The pressure at the dead ends becomes undesirably low in the case of additional extensions. It is also true. So option B is correct.